So parametric equations is when you have one equation for x, one equation for y, and x's and y's are doing different things. All right, and then you have this thing t called the parameter, which is usually time, but it's just another kind of variable that can restrict the curve. So if I want to graph this parametrically, I plug in values for t into both equations. So when I plug in -2 in here, I get -2 squared, right? -2 squared is 4 times 3 makes 12, okay? And down here I get 12 as well, yes? And then when I plug in -1, I get out what? 3, and then I get 3. When I plug in 0, I get out 0. And then for y, I plug in the same numbers. -2, I get what? 0 squared, 1? I think you're thinking something to the 0. Anything to the 0. No, 0 squared is just 0. Okay? And then, so then I plug in -2, I get out -4. And then I plug in 3, I get out, or -1, I get out -2. I plug in 0 for y, I get out 0. 3, I get, or 1, I get 2, and 2, I get 4, right? So then, looking over here on it, if I were to graph this on an xy plane, let's start over here. Let's start over here where this is 0, and this goes up to 10 or 12. 1, 2, 3, 4, 5, 6, 7, but this is still the y-axis over here. Let's call this 0.
Okay,
So we're just going to graph. Here's the x-axis, okay? And this is going to be the y-axis, but it's going to start at 0. So we're not looking at, we're just looking at quadrants 1 and 4, more or less, so that I could graph this, so I could see everything.
Wait, if it starts at 0, then this corner is 1.
No, because this is negative down here. This is x is 0. This is y is.
Okay.
So this point would be 12, -4. Is this 6 in each spot? 1, 2, 3, 4, 5, 6. So 6, -4 would be down here. 1, 2, 3, 4. And 12, -4 would be there. And 12, +4 would be out 12, and then up 1, 2, 3, 4. And I changed that graph so you could see everything. And then 3, -2 would be out 3, and down 2, and out 3, and up 2. And then 0, 0 would be here. So this looks like a
Parabola.
sideways parabola, which kind of looks, whoops, like this. But, whoops, it doesn't go down and below, it just goes straight. But because the parameters say just between -2 and 2, it's only part of that parabola. It doesn't go on forever and ever. So this allows you to restrict that function. Get it? Okay, so that's how you graph something parametrically. Okay, moving on. I'll talk about how you set up your calculator to do this and stuff. But set the mode, blah 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 blah. So we'll set up. I could show you that this would graph that parabola, but I'm not going to do that right now because you'll have some other chance to do that. Find the corresponding rectangular equation by eliminating a parameter. Okay, so for this one, what you want to do is solve one of these equations for t, and then plug it into the other equation. All right. So this is the same thing we just did, right? Isn't this the same equation? Okay. And so what I'm going to do is I'm going to solve y for t because it's easier. So y is equal, or t is equal to what? Y over 2. And then I take that and I put it in there. So I get x equals 3 times y over 2 squared, which gives me x equals 3, and when I square a fraction, I square both things. 3y squared over 4, or x equals 3/4 y squared, which if I want it in standard form as we're doing in this chapter, y squared equals 4 over 3x, which is a sideways parabola, right? Which agrees with what we just did, right? That opens to the right and has its center at 0, 0. And in this, it says eliminate the parameter. So in this case, we're not worrying about restrictions. So this one would go on forever and ever and ever. All right? Questions about that? Okay. So this next one is kind of a trick, and you should pay attention because I have one like this on a quiz, and people don't know what the trick is. So I'm going to show you the trick. All right. So the trick for this one is you write cosine of t. You rewrite, so this, if I graphed it, I would get an ellipse, a circle, I believe. So x equals, cosine of t equals x over a. And sine of t equals what? What's sine of t equal if I just solve for sine of t?
Y over A.
So y over a. And then we also know that sine squared, remember this? Sine squared of t plus cosine squared of t is equal to what?
1.
Equals 1. This is from, first semester. Yes, sir.
That doesn't make a cycloid?
A cycloid makes a circle.
Okay.
I'll show you. You're close. Okay? So the reason this makes a circle is because based on this relationship, then what I can do is I can take this and plug it in here, and take this and plug it in here. And so I get y over a squared, because sine of t is y over a, so sine of t squared is y over a squared, plus x over a squared is still equal to 1, which gives me, I'm just going to flip places with these, x squared over a squared plus y squared over a squared equals 1. And if I multiply through by a, I get x squared plus y squared equals a squared, which is an equation of a circle with a center of origin. So watch, I'll show you how you could do this on your calculator. It's kind of cool to graph something parametrically. So if you go to your calculator.
Can't you graph like someone throwing a ball on like a...
Yeah, then we're going to do that in the next problem. Okay, so just hang tight. We'll get there. So the next one, so now we're in polar mode. So you have to change mode. We're going to make sure we're in radian. We're going to go down to parametric.
Yeah, it says to be a degree.
Let's be it. No, don't look at it. Pay no attention to that man behind the curtain. Okay? Because it says from 0 to 2 pi. So we're going to be in radian. Okay? So parametric, we're going to be in radian mode. We're going to set this to simultaneous. Okay? And then now we're going to go to y equals. And if you look at y equals, you have an x and a y. So each pair of x and y values, that's for one parametric equation. So just for kicks, I'm going to put in a number for a. So let's say we want a circle with radius 3, right? So I'm going to put in, so I'm going to make my equation 3 cosine t plus 3, or x is 3 cosine t. Get rid of this. Okay? So x is 3 cosine t comes up, right? And y is 3 sine t. Okay, I'm not going to graph it yet because I want to mess with my window a little bit. So I'm going to go up to window, and so this means I'm going from 0 to 2 pi. So I'm going to generate t values just like this, 0 to 2 pi. That's what that means. T step, I don't know where that comes from, but I would have it set as something pretty small, like 0.1 or something like that. Because if you do it 1, that means it's just graphing points every not very frequently. Okay? Now, since I want this circle to go between, I want the vertices, or the circle doesn't really have it has a radius of 3. So I'm going to set this to like -4 for x min and +4 for x max, and then same thing for y min and y max, -4 and +4. And then hopefully I did everything correctly. And if I hit graph, there it's a circle if it was a square viewing window. See, these spaces are smaller than these
Okay,
spaces.
mine made a triangle.
It's actually a circle. So if I go zoom square 5, zoom square,
What's the equation?
then I get a circle. See? Okay.
3 cosine t.
Get it?
3 cosine t.
Isn't that cool?
I made a triangle.
That's fantastic.
But I-
Probably because your step is too big.
Oh,
That
so
I
it's
bet
not supposed to
set
be-
this to because it's only graphing like 3 points. You see,
So it's
So-
like 0.5.
or point. There you go.
Okay.
Got it? So yeah, Cameron got a triangle because it only graphed, like he had a step too big, so it only graphed like 3 points and connected them. You know? So that's what happened there. All right, so going on. And yes, sir. It's really slow.
With this here off the top of
Probably your
head,
step is too
do
small.
you remember
Yeah.
the friendly window?
If it's graphing, what?
Do you remember the friendly window?
I remember the friendly window. All right, but we gotta move. We only have till 15 after. All right, so with this one, you will see one like this, and this is Jim or Tiger Woods who had hit a golf ball with initial velocity of 150 feet per second, an angle of 30 degrees to the horizontal. Find parametric equation. So they give you the equations. This is the x. You might have done something like this in physics. Yes. Yeah.
We did this in
Okay.
algebra too.
V sub 0 is the initial velocity in both cases. Theta is the angle at which it's being launched. And g is the acceleration due to gravity. And if this is in feet, feet, that's 32 feet per second, right? Yes? You know that? That's per second, right? So it's speeding up 32 feet per second every second. That's what that means. So x equals v sub 0, which is 150 cosine of 30. Got it? And if I simplify that, that's equal to 150 cosine of 30. I know you all know is square root of 3 over 2. So x is equal, whoops, I forgot a variable, t, right? So that's equal to 75 root of 3 t. That is your horizontal component of Jim hitting the golf ball. All right? And then the vertical component is going to look like y equals 150 sine of 30 degrees. Whoops, sorry, I forgot the first part. Okay, sorry. -1/2, so it's -1/2 of 32 feet per second, which gives you 16 t squared.
Would it be negative 15?
No, because it's the gravity is positive, right? Wait, negative. It's a negative. Is it? Oh, you're right. It's -16 t squared, because that's the force pulling it down, plus 150 sine of 30 is 1/2. Do you believe me?
Yeah.
Believe me, times t. And h, that should be like h sub 0. That's where it starts from, and since he's hitting it off the ground, right, that's just 0, plus 0. So when I simplify that, I get -16 t squared plus 75 t, right?
How do you get the negative 16 or t squared?
Because g is 32 feet. This is just I would give you this. 32 feet per second squared is the acceleration due to gravity. That's a constant, okay? All right, so we did that. How long is a golf ball in the air? So to figure out how long the golf ball is in the air, you have to figure out where this is equal to 0. Yes? Because that's because one component is pushing it this way, and the other component is pushing it up. So your net effect is it's going up and down, and this is pushed. So net effect is your ball is going to be doing that. You understand that? Okay. So then, how long is a golf ball in the air? So the way you can do that is finding this in itself makes a parabola, and you can find the vertex of that parabola by going negative b over 2a. Okay, that's the x-coordinate, comma f of negative 2 over va, but we don't need that. Okay, so I'm going to plug in negative 75.
Why are you finding the vertex?
Because they want to know. Oh, that's wrong. Sorry.
We find
That's wrong. That's wrong.
the 0.
Okay. I want to find out where it's equal to 0. Okay. So I said this equal to 0, and what I could do there is factor out a t. Right. So I get t times negative 16 plus 16t plus 75. I should look at my notes when I do it. So one place that the height is 0 is when t equals 0. We know that because that's where it starts. And the next place where t is equals 0 is when this thing is equal to 0, or when 16t equals 75. So if I divide, no, I brought that over onto that side. So I get 75 divided by 16, so I get like 2.4 or something like that. Can someone do that?
75 divided by 16?
Yeah.
4.6.
4.6? So 4.6 seconds is how long is in the air. When is the ball at the maximum height? Well, it'd be the maximum height, since this makes a perfect parabola, it'd be at maximum height at half of that. You understand that? Okay, because it's going up and down, and it accelerates and decelerates at the same rate. So you could just cut this number in half. So that would be at about 2.3 seconds.
Do we need to know how to find what the maximum height would be if we don't already have how long it would be?
Yeah, you could go negative b over 2a. Right, that would give you the time at the vertex. So if it didn't start at 0, like if you were hitting off a platform and doing something like that, okay, then you would have to use negative b over 2. Okay, determine the maximum height of the ball. So what you do is you take this number and you plug it in to this equation. Okay, so you plug it in there and in there, and I think you get 180. I'm not sure.
You plug it in for what?
You plug it in for what? Yeah.
Why not x?
Because x gives you the distance. We're getting to that, right? X gives you how far it goes. So according to my notes,
Isn't that what it's asking? Determine the horizontal distance.
not yet. The last question asked you, okay?
Oh, we're not on the
Yeah,
last
we're
one.
still on
Okay.
C. So I got 4.687 seconds. It's in the air, and 2.34 seconds, and I got a maximum height of 87.89 feet. Okay, if I plug that in, so I get 87.89 feet. 87.89 feet, and then determine the horizontal distance the ball travels. Well, this should actually be 4.687 or something like that. 4.687. And now to determine the horizontal distance, I take this and I plug it in to my x equation, right? So I'm going to take that and plug it in over here, okay? And so if I go 75 root of 3 times 4.687, I get that the ball travels approximately 600 and something feet, 609 feet. About
Wait, can you do that?
75 times square root of 3 times 4.687. I just plugged into my x equation.
No,
Think
forget
we're gonna have time
that.
to do the rest of the problem.
Okay? What? Yeah, we're not going to have time. But I do want to show you how to plug this into your calculator. We're not going to have time to finish up. Okay? So,
Just plug in the equation.
to do this on your calculator, class, yeah, you always in front. So, second clear, whoops, y equals, that's what I want. So I'm going to clear this one, and in there, I'm going to put in x, 75 root of 3. 75 second square root, is this square root? That's square root. Square root of 3, move over t, okay? And in the y equation, and it clear, I'm going to plug in negative 16t squared, hold on, plus 75t. And you're going to say, why isn't mine working? Because you have to mess with the window, right? I know that it's going to take about 6 seconds. So this is where you have to think a little bit. It's going to take about, how many seconds did I say? 6 seconds, 4 seconds. So let's set Tmax at 6. T-step, I'm going to keep small like that. X-min, I'm going to set at, let's just say -1 or something, so I can just see my axis. X-max, what do you think I should put in there? You know it goes 609 feet, so let's put in 700 feet, okay? Hold on. This one's in degrees, does it matter? Doesn't? It doesn't matter because I don't have a cosine or sine. Y min, I'm going to, sure, I'll keep that -4, but Y max, I'm going to set to like 100 because I know, I figured out that it went up to 83 feet, remember? And then if I hit graph, let's see what happens. Okay? There goes my ball. Launching. If I want to slow it down, I want to put something like in here. So if I want to slow it down, clear, let's plug in like 0.02 or something. And then if I hit graph, I can see the ball being launched by Tiger, and there it goes. Okay, do your homework up through, let's see what homework problems you can do. Hold on, just your homework.